This conference will now be recorded.
So today we are going to see decorators. Um, so decorators can you can imagine it as a function which modify the functionality of another function. If you have function A and you want function A, but you want a little modification in function A, you can use a decorator to do that. And so to explain decorator, let me build up a function. So we all know how to create a function. I'm just giving def function. Let it be a simple function. I'm just telling return one. When I call the function, the output would be one. So it is because it is returning one, right? Actually, previously, while discussing about the scope, we were like, I mentioned that what is global variable and what is local variable and what all the methods you can use to identify what all the globals and locals available. So we can use locals and globals to know what all the locals declared inside the function and what all the globals declared. So here I'm declaring a variable called s, which is above the function, so which is a global one. And here, this is my function. It's called check for local. And here I'm inside calling locals method, which will give me the locals available. I'm also calling globals outside the function. So it is printing me everything. Hmm. So it is telling check for locals as a function it could find, and it found as global variable. These two things it found. So this is kind of a dictionary. It is telling name is equal to main. This is a main program, and it is telling document it is equal. Could you see it is in the form of dictionary, key and the value. So here it is telling doc is automatically created module from interactive environment. How we created this page, it is telling, and we don't have any package. So it goes on like that, and here it is telling is. So we get back a dictionary of all the global variables. Many of them are predefined in Python, which was not defined by me in this page. So let me only get all the keys. So here I'm getting all the keys. I'm just giving globals dot keys, and then so these are the keys available here. I could see yes, right? Whatever what we declared. So I'm just telling in this dictionary I want only yes. It is telling the value saved inside is global variable. So till now what we did, we create a variable, we created a function, and outside the function I'm having a print statement which is called global. So we were like printing the output of global and saying it as in the form of dictionary, and then we got all the keys of that particular dictionary and particular variable inside that dictionary. So now I'm just going to call the function, which is nothing but it will print locals, right? So it is saying there is no local, nothing declared inside a function. Now let me create a new function, and it is called hello, and it is going to return hello plus the name. My function is created. Now I am calling the function. So it is going to print me hello juice, right? So here I am creating one more variable called greet, and I am saving hello inside it. Okay. And later what I am doing, I'm just trying to print greet. It is telling it is telling hello is nothing but a function, right? What is hello? Hello here is a function. The function name I'm saving it into another variable. So it is here I'm not using parenthesis. When you do this, when you assign a label to a function, this is nothing but assigning a label to a function. This is a function. I'm giving a label, a new name to that particular function. Note that we are not using parentheses here because we are not calling the function. When you give parentheses, it means you are calling a function, but we are just passing a variable. We are passing the name to a variable. So I don't give parentheses, but I'm giving a new label to this function. When I print greet, it is telling it's a function. Greet is nothing but hello. Hello is nothing but a function. This is a function and this is a variable of the function. It's printing me that. Now let me call the function using greet. It is going to give me the same thing what we got when we call the original function. Now the thing is, so what happens to hello? I'm again, let me again use hello and see if it is working. Yeah, working. So now let me delete hello. So what will happen when you delete the name called hello? What do you think will happen when I delete hello? Just guess because this is a new topic. I know you are not aware of it. I'm just asking you to guess. What do you think will happen when you delete hello? Okay, great will point to null. Good. Any more answer? Okay, greet will give hello Juice.
Already it is assigned to grid, so it might give the result as
Mhm.
follows. Just
Okay, let me try that. So I'm deleting the hello. Okay. And then actually I tried deleting twice. That is why I see this. Because I already deleted. And again I'm trying to delete hello. That time it is not present because it is already deleted. So that's why you see this error. So now I am calling hello. So it is giving me name error because there is no name called hello because we deleted it from the memory. Now let me call greet. It is giving me hello. Even though we deleted the name hello, the name greet still points to the original function object. It is important to know that functions are objects that can be passed to other objects. So it is the original object is passed to greet. It's still pointing to the object here. Just the name got deleted. When we delete hello, we are not deleting a function. We are just deleting the name. So we cannot find the name again anymore. But the greet is still pointing to the original function object. So that is why we could see output. Now let's see another example. Okay. So let's see function within function. So in the previous example, we saw how to treat function as an object. Now let's see how we can define function inside another function. So here I have a function called hello and the parameter name, and I have a print command to know that where I am. So now initially I'm printing hello function is executed, and then I have another function called greet. So I'm just mentioning here that if we are inside greet, and we have another function called welcome. It is also mentioned here. Now I'm calling the greet. So initially this will be printed. When I call greet, this will be printed. When I call welcome, this will be printed. And now we are back inside the hello function. We went inside the other nested function, then we are printing. So all this happen inside the function. You see the indentation, it's not outside the function. Everything is inside the function. Let me run this. So I'll give hello. You can see it gives me everything. All the print statement. Let me try welcome. It is giving me name error because when you try calling welcome, it will check in this indentation level only. Indentation level 1, it will check any function is declared as welcome. It couldn't find it. It will not go inside hello because it now we are not calling hello, right? So it is not going inside hello. It will check in level 1 indentation. It couldn't find welcome, so it is giving me a name error. See, this is about scope. Note, due to scope, the welcome function is not defined outside. Now the welcome is local to hello, right? So when you call a function outside, it will go and check all the global objects only. It will not go and search for all the local. So it is not anyway giving me output. It is giving a name error. Now let's see about the returning function within the function. So here you see hello and greet and welcome. And I'm telling if name is equal to Joe's, return greet, else return welcome. So here I'm returning the function. I'm not calling the function. So let me run this. So inside hello function, I have two local function, and I'm having a if condition to know which one to call. So now let's see what is returned. So let me now assign this hello to X. Okay. So here you can see I don't have anything inside the open bracket. I don't have any name is equal to Joe's. So if name is equal to Joe's, it is going to greet, else welcome, right? Because I don't have any name here. So now let's see what function is returned if we set x is equal to hello. Now I'm going to call x. So it is telling me it is a local function, it is greet. Now let's print it. So what you guys are happy with this output? When you print x, it is giving me the greet function. And here also it is giving me greet. Are you guys happy with the output? Please say yes or no. No. Why, Sarisha? Sarisha, you can unmute yourself and talk.
Yeah,
Why do you want to unmute?
like you are saying if the name argument is Josh only, it should return right.
Mm-hmm.
It should return welcome, right?
Okay. So now let's take a quick look at the code again. In the if else clause, we are returning greet and welcome. We are not returning greet
Function, we are
open and
not
close
returning.
bracket.
Okay, got it.
So we are not returning greet open and close bracket and welcome open and close bracket. We are not doing it. We are just giving greet. Not here. I don't see any open and close bracket, right? This is
Yes.
because when you put a pair of parentheses after it, the function get executed. When you put a pair of parentheses here, the function will go and execute it, right? Whereas here, if you don't put parentheses after it, then it can't be passed around and cannot be assigned to another variable without executing it. So when I write x is equal to hello here, hello gets executed And because the name is Joe's by default, here the name is Joe's by default, because I have here directly, right? I need not give while passing. If I just have a parameter name and then I have to pass a value for the parameter. If I have X, I have to pass what X is. But by default, I have Joe's already here, isn't it?
Yes, Anu.
Uh, so now let me show an example for you to understand this further. So now let's assume I'm just giving X is equal to hello, name is equal to Sam. So now I'm changing the value to Sam. Okay. Now I'm calling X. So it is giving me welcome. And then so this is inside welcome function, because now we change the name to Sam. This got changed and the name is not equal to Juice because it is Sam. So it is going to welcome. Is it clear now? Any
Yes,
doubts?
Anu.
So I have written whatever explanation I have said now, I have written it here, which will be helpful when you refer later. So now we saw having a nested function. We just saw labeling a function and then we deleted and we called with label. And then we saw a nested function inside a function. And we try to call the inside function within the function itself, within the main function itself. When we call it outside, it is not going to give you any result. It is going to throw you an error because it cannot find the particular function. And we also saw how to alternatively call the function. I can have n number of function, but based on the condition, I might call anything else. I mean, I can call one among them. So we saw all these things in nested function. Now let's see passing function as a parameter to another function. Okay. Here I'm going to pass a function as a argument. So here I have a origin function one called hello. I'm returning something, and I have another function called other, and here the parameter is function. If you want see means I'm passing function as a parameter. This is not a variable. Usually we pass variable. While calling this function, I'll give assign value to that variable, isn't it? But now I'm passing another function as a variable, and then we are going to print the original function. Now let's see if I call hello, sorry, if I call hello, it is going to give me hi juice, correct? Expected, as expected it is working. And if I call other, so here I have to pass a function parameter, right? The parameter is another function. I have to pass another function here, isn't it? I'm just passing hello because that is the only function I have. I'm passing hello inside other. So it prints as it is, whatever is there inside here. And then it is calling that particular function, which is nothing but hello. So it is calling hello. Now the control goes here and then it prints this. So you can pass function as an argument to another function. Clear? So now having understood on all these things, now we can go and create our own decorator. Okay. Now we are like into this topic called decorator. To understand decorator only, I was explaining all these things. Actually, yeah, in the previous example, this example, we manually created a decorator. I'll I'll show that. So here I have this function 1 and function 2. Inside function 1, I have one more function. Okay. So I have a wrap function, and here I have a function as a parameter. For this function, I have a parameter which is nothing but another function. So here we have declared one more function which will be executed only when you call this function. And here I'm calling the function which is passed as a parameter, and then this will be printed so that you will know that this is called and this is done. So after that this will be printed. Then we are returning wrap function. Later we are returning it. So this is another function I just created because this can be passed to this function. Okay. Is this program clear? Any doubt here?
Can you explain again?
Okay. So here, do you understand that we have two functions? One is new decorator and function is decorator. Two function we have. Did you understand that part?
Yes, first indentation, so two different
Ah,
functions.
hmm. Then in the inside first function, we have one more local function. You understand that part?
Hmm.
I have one local function. Okay. And you can see that for this function, the parameter is another function, some any other function defined in the same Python. Okay. So
Yes.
the function I'm calling it here. This you understood?
So the new function which you are going to assign there, you are calling that inside the.
That's what we did here also. See, I have function. I'm then calling that function because I do not know what is this function. Whatever name is assigned to this variable will be called later. That's what we
Hmm.
did, no, in the previous example.
Okay.
Like when I call other, I'm just passing hello. This is nothing but a function. I'm passing hello function here, and that hello will be called here. That's why when you call this line is printed, then it is calling the function which is passed, which is nothing but hello. It goes to hello and print what is there inside hello.
Hmm.
Correct?
Yes.
So that's what we have here. Main function, we have two main functions, and inside that we have one sub function, and then we are calling this parameter.
Okay.
So now let me call this function, second function. It's pretty straightforward. Whatever is there will be printed, right? Now I'm going to call the first function, which is nothing but new decorator, and then I'm inside. I have to pass a function, right? I'm passing this function as a parameter to the function number one. Let's see what is printing. It is printing new decorator is there, and inside local we have one more function. See, if I call this function, the main function, new decorator, it is not printing me anything. When I call this other and I pass another function here, it is printing me something. One is print statement, the other is return statement. Both are printed. So let me do one thing. I'll reassign the function. So like we created greet in the first example. We had something called greet and we assigned a function to it and then we called greet, isn't it? The same thing I'm going to do it here. So to this function, I'm assigning this. To this variable, I'm assigning this new decorator function needs decorator. And then I have assigned it. Now I'll call this function need decorator. I could see this one. Code would be there. First line is printed. And then second line is it is calling the function. So it is going and printing this. And third line is code. This is also printed. So what happens? It goes inside this function. This is a function declaration, right? It just declares, it is not going to print anything. It just declares everything inside the memory. Then the second statement is return wrap. So it now goes inside wrap because it has to run the wrap. I'm running the wrap function, and while I run this, line number one is printed, line number two, it calls this function and prints this, and line number three is printed. So I just reassigned a function to another function. So here what we did, we just modified the behavior of this function, right? Initially, when I did function need decorator, the output was different because that's what we declared inside it. But now I modify this function completely because I reassigned something else to this function, and this is getting called whenever I call this. Now here on, when I call this function, it is going to nothing but it's going to call this function new decorator, isn't it? This you got that we reassigned and this is getting printed every time. Is this clear? What we're doing in this reassignment? We're just assigning function one, like how we assigned hello to greet. Similarly, we assign this to a new function and then I'm calling this. But here the thing is this is already a function name. In earlier example, greet was it was not there anywhere. We created a new variable and we called here and just reusing the original function name, but still it's not going to mess when I call this function, this when because I passed this function need a creator as a parameter to this, right? And here I call that, right? Here I call that function, right? It's not going to create any mess. So now we are going to see decorator. So what we did here, like how we created a function and then we reassigned everything, that we will do using decorator. Decorator starts with an at the rate symbol, which is what Python uses for decorator. This is called decorator. When you see at the rate symbol, you know that it's a decorator. I'm just telling new. So I'm just passing this name, new decorator. Okay. And then I'm just running this. Now let me call this function. So it gives me the same output. So instead of writing this way, I did this way. So whenever I first created function 1, and then before creating the function 2, this function, I'm just giving a decorator. I'm just telling at the rate new decorator, which is nothing but another function, right? Which is nothing but the function 1. So when I give this, it means this. It means nothing but this. I'm just telling this function, no, that is reassigned to this name. I'm reassigning new decorator, and inside the new decorator, again, I'm passing this function. So instead of writing this line, I'm just writing this. I'm just telling new decorator, which function I have to assign to this name. I'm just mentioning with the under at the rate symbol. So this is how you build your own decorator manually. Actually, you will use this decorator things a lot if you begin using Python for web development, such as Flask or Django. When you do web development, you will be like assigning, reassigning function to another function. There you will see lots of uses of this decorator. So instead of writing this, a shortcut is I'm doing this. That's all. Before defining a function, I'm just telling at the rate new decorator, the function name, function one name. Clear, guys? So first you should understand like few things. That is, you can give a new label to a function, and you can call that label instead of calling the function. Even if you delete this variable, I can still get output of this new variable. Okay, I still get the output of new variable. The second thing what you have to understand is I can have some local function that you already got an idea. And then the third thing what I want you to understand is that we can create a new variable, and we can assign a function to a variable. Here, instead of creating a new variable, I'm just using the existing function name and I'm assigning another function to it. That's all. The only difference is instead of variable, I'm using a function name. But instead of doing this assignment, I'm just using the decorator at the rate new, which is nothing but this statement. Whatever comes after this, no, after the decorator, to this name, I'm going to assign this, and in for this function, there is a parameter which is nothing but another function, which is again I'm going to pass this. That's what I'm defining here. This is nothing but this. That's all. This is all about decorator. If you are clear that we can have a sub function, local function, and we can call the function with another label, then when you understand that decorator is nothing but a shortcut to do a reassignment. That's all. You can imagine that. Now let's see a new topic called generators. Generator and iterators. Mm. So in this section, we are going to see what is iteration and what is generation, what is the difference between them, iterators and generators, and how we can construct our own generator. Generators are used to allows us to generate uh, everything in memory. For example, you saw like range. When you give range 0 to 0 comma 5, it is going to give you, and then you print that, then you will see print 0. 0 will be printed 0, 1, 2, 3, and 4. Till 4, it will be printed, right? It is generating something on its own. I'm just giving the range from way to way. Similarly, something like that. Uh, but generator, we also create a function. We use def keyword and then we have return keyword inside the function, right? That's how we create function. But generator function will allow us to write a function that will send back a value and then later resume where it left off. So this type of function is a generator in Python, allowing us to generate a sequence of values over time. The main difference is the syntax. We use yield, yield, yield. Um, in other aspect, generator function will appear very similar to normal function. It's similar to normal function. The main difference is that when a generator function is compiled, they become object and then they support iteration. This means when they are called in your code, they don't actually return a value um, and then exit. Usually, what does the function does? It builds some logic to that, return a value and exit, right? But instead, the generator function will automatically suspend and resume their execution at the last point. So, like instead of having the main advantage of having generator is instead of having to create an entire series of values upfront, the generator computes one value and then suspends its activity, awaiting the next instruction. Then it again starts the activity. So it does something and then it waits for our signal. Then again it starts. Usually the function doesn't do that. It compiles everything inside function, return the value and exit. That's all. It's done. We cannot go back unless otherwise we call it again. But this is little different. Let me show an example, then you will understand. So here I have a function called generate cube, and in the range of n, whatever you pass as n, I'm just going to run this command, which is nothing but exponential to the power of 3. That's how you create cube, right? Which means n into n into n. So here you see I'm using a keyword called yield instead of return, right? Let's see. So I have for loop for x and gen cubes 10 print x. I'm just calling this function. I'm running this function in loop for 10 and then I'm printing it. It is giving me the output. So we have seen a Fibonacci series in the past, right? So let's create a generator which will calculate the Fibonacci numbers.
Why we are using for x in GenCubes? Directly we cannot use GenCubes function there. Already we used for loop here, right? Range of
I
n.
can do that.
Print.
Because we have yield inside it, right?
Hmm.
Let me show, let me proceed. You will understand why we are doing this. See, let's generate, let me open the Fibonacci series, how it looked. Then you will understand the difference.
Okay.
Tilly gave us a demo on Fibonacci. Okay, okay, I got it. So I'm just telling, okay, so I'm just telling the n, I'm just getting the n num as a input, and then I'm just defining a number, and then inside that I'm checking if it is less than 1, because if it is less than 1 or 1, then we can directly print 1. If it is less than 1, for example, it is 0, then also we can directly print it. If it is a higher number, then you go for a Fibonacci series, which is nothing but number minus 1 and number minus 2, because n minus 1 in plus n minus 2. You again go and call, when I run this, no, Fibonacci number minus 1, it again just reduces an input, the parameter minus 1, and again, for example, if the number is 3, it is going to go and call Fibonacci of 2, because 3 minus 1. Plus again it calls this. It's again goes here and then it calls Fibonacci of 1. Then what happens again when you call Fibonacci of 2, it is nothing but it again goes here, right? At this point. Again it is 2 minus 1. It is going to call Fibonacci of 1. So it goes on until, for example, if you have 5 as a number, it goes on until you have 1, until you reach the point 1. Because when you reach the point 1, it is going to return the number. Then later it will have all the other remaining number. It will plus everything together and return you something, right? So this is how it works, right? But here I need not go and call the function again and again. I'm just giving generate Fibonacci series. I'm just passing n. And here I'm just initially assigning a and b is equal to 1. And for I in the range of n, yield a. And again what I'm doing, I'm reassigning a to b and then b to a plus b. It does the same thing. I'm not calling the function again and again, because here your memory cannot hold in the normal scenario. Here it is. Okay, in the normal scenario, your memory cannot hold everything at a stretch. That is why first we are calling, saving some value in memory. Then again we are calling, getting some other number and saving it into memory. Again we are calling, like that we are going on calling and giving new value to the memory. At the end the memory will add everything it has inside that particular placeholder. It goes and adds everything up and returns you. But with generator I don't have this memory issue. It can do everything in a single go, so you need not have to keep track of every single thing we created. Here it has to keep track of all the numbers. Let me run this inside Tony. So initially it is going inside the function. Okay, it knows. Okay, line number one is function. Then it will go to the next indent, the same indentation level. Next statement. Here nothing but we are calling a function, and then it goes inside function. If number is less than one, okay, it is less than one. I mean, it's not less than one, so it is going to the else. And again, here you see we are calling the function, the same function again in a recursive way. So now it has created one more. Here the function is there. It has created a new pop-up. Here you see it. This is now how it happens is in the memory. This is there, and from there it is creating a new memory and then doing a new analysis. Again, here you see it is going to call number 6. So again, new window is opened. So it goes on. See, for example, here it is just evaluating the first return statement. The second Fibonacci is still there. Just with the first, it is opening a new window, right? New memory is getting created. Multiple memory is getting created. Again, okay. Okay. Now again it goes back. Again it evaluate the second Fibonacci. So it goes on. Many memory is getting created here, right? This will go on until it has all the values of from all the memory. Now initially the memory, each memory will hold a new function with a new variable, right? Only the parameter changes. The same Fibonacci is called, only the number inside that is changing. So it is having every multiple memory. When each memory has some value, like the final value, then it goes and gathers all the data from all the memory, and then it sums up, and then it returns you the output. So this is what will happen. If I go on with Tony, it will again create few more memory, and then it will do its work. But instead of doing that, okay, instead of doing that, we are doing here we are doing it using generator. Here I'm telling it generator because I'm giving yield. I'm giving yield A. when you feel when you see a keyword called yield, which is nothing but your inside, you have created a generator. Let me create. So here I'm just calling the function gen Fibonacci, and then I'm printing the number. Okay, this I haven't executed. Okay, I'll execute this first, then this next. It is giving me the output. Let's see this inside Tony. So here you can see there is no multiple window opened, right? Inside the same window it does everything, which means no multiple memories are created within a single memory. The same memory is reused. Is it clear now? why there is a difference between the old code and new code. Rajita, Tilly, Sam. Here, the same memory is reused again and again. We are not creating multiple memory. In the earlier case, we have to create all the memory, and a link also should be executed in all the memory. That's how you can come return back. When all the memory has a solid value, in the reverse way, it gathers all the value from each memory and then it sums up and it gives you the output. Okay, you have to create multiple memory and also link between all the memory so that it goes back in a reverse order. Correct? But here, a single memory. Inside a single memory, we do everything. So this is the only difference between the normal function and a generator. When we go generators, generators are best for calculating large set of result. Here we have large set of result, right? Multiple result we have, multiple sets we have, and then later we use all the set together. So in that case, we need not allocate multiple memory at the same time. So that is when we go for generator. So when you write a program, initially, you will be thinking only about the functionality, whether my program is able to give the result the user is expecting, whether the functionality, if I am telling write a program to do this, do that. Initially, you will be focused on creating output. Initially, you will be focused on writing a program which will give me that particular output. Okay. The next thing that plays a major role is performance. How much memory it is using, how much CPU it is using. CPU is nothing but number of times you evaluate CPU cycles, and memory is nothing but how much memory you use, because both memory and CPU is it's nothing but money indirectly. When you have a computer and you have some RAM, you store everything there, right, in your computer. And when you're out of that particular memory, like uh, you have maybe 1 TB and you have photos, files, everything stored inside that, and now you're out of memory. What you have to do, you have to go buy extra hard drive, right, to save that. You have external hard drive where you can, which might be of 1 TB or 2 TB depending upon your use case. You will be buying a external hard drive, you will connect it to your computer, which is nothing but extra money you're spending on for memory, right? Similarly, when you run your program, it will be running over hard drive, and somebody, your application owner, might be paying for that particular hard drive for what he's using. When the memory capacity needs to be increased, he has to pay extra amount, right? So here the memory plays a crucial role, because memory is nothing but money. How much money you're going to spend. Like if you have very few items, then you can go and opt for one bedroom room apartment, where the rent will be way more lesser than three-bedroom apartment. Similarly, everywhere it works in a memory CPU. Here with this yield, with the generator, you are saving the memory. So that is why we generally go for generator when we have to calculate a large set of result, which will need multiple memory allocation. But in the case of generator, we don't want to allocate all the memory. We can just get the result at the same time. Here you see, whenever I print, it is directly printing me the Fibonacci series, right? It started printing already with the single memory. It started printing one, one, two, and then it goes on. But with the previous example, it was not printing anything. It's just creating a memory, and calculating everything. Later, it might create eight more window, eight more memory, and then finally it prints me everything. But here you see, already three series of the Fibonacci is already printed with one single memory. It started giving me the output. So this is a use case for a generator. This is why we go for generator. Whenever there is a large memory calculation, since we have a generator, we need not have to keep track of all the memory and create all the memory. That's the only difference. I have given the explanation here. Later you can go through it. Whatever I have said now, I have printed it here. So here we had seen Fibonacci with the general way how we write, right? How we initially wrote Fibonacci series. We saw that code. What if the number I have given number 8, right? But what if I give 1000, 10,000? How much memory it is going to create? Imagine. With 8 only it is creating multiple memory. What will happen if I give a value like 10,000, 20,000? It is going to crash my memory, right? Isn't it? So memory we have to, while writing a code, after we have an output, we functionally achieved the result. The later part you have to focus on is the performance. That is, you have to give the worst case scenario. Here the worst case scenario is 1000, 10,000. 10,000 is a worst case number. Maximum number I'm assigning, I'm seeing how it is working. Minimum number I'm assigning, I'm seeing how it is working. Average number I'm assigning, I'm seeing how it is working. Okay, then there is a huge difference between minimum, maximum, and average, how much memory it took. When there is a huge difference, then I take only the worst part and say this is how the program is going to behave. And so the worst part is actually scary, so I have to do something to make it better. But with generator, when you go for generator, you can imagine minimum number, maximum number, and average. For everything the memory going to be the same. Even though it is 10,000, it might take multiple CPU because it is going to find the number and print one by one until 10,000. But the memory is not going to get multiplied here, right? Even in the worst case, the memory is same. One single memory is enough to print everything. So here in the generator, my average case, worst case, and minimum, the best case all look same, the memory wise. So I will go and opt this generator. So that's how we usually code and then improve the performance of it. Clear? Rajita Tilly? But since we saw multiple topics today, it might be little overwhelming. What you can do, I'll send out this file. You can rerun again and again. Okay, you run it again and you will understand. You just have to by heart. You already understood whatever I say, but you don't remember later. So you just have to by heart that. We have a little more portion in generator, which is called iteration, that we will see tomorrow. I'm just saving this. Okay, I'll send out over mail. Okay, guys, if you don't have any doubts or anything else to discuss, we can wind our day here.